Question says how many liters of chlorine gas at STP will be liberated by the oxidation of sodium chloride with 10 gram KMnO4. 10 gram KMnO4 is given there, and in the presence of strong oxidizing agent, sodium chloride is undergoing oxidation reaction. First of all, we write down the chemical reaction. Pay attention very carefully. We have a strong oxidizing agent KMnO4 and plus. Now sodium chloride is there and it is undergoing oxidation reaction. First of all, we write down the oxidation number of sodium and chloride ion. Sodium is present in +1 and chloride ion is present in -1 oxidation number. Now pay attention carefully. Sodium is present in its maximum oxidation number, hence it cannot undergo oxidation reaction. You can see it will not undergo oxidation reaction, means it will not participate in the reaction. And Cl minus, it is present in its minimum oxidation number, then it can undergo oxidation reaction. Chloride ion will undergo oxidation reaction. It means that when KMnO4 is reacting with NaCl, only Cl minus ion will participate in the reaction, undergoing oxidation and converting into Cl2. So Cl minus ion only participate in the reaction, undergoing oxidation reaction, converting into Cl2 gas. And always keep in mind, since the medium is not given there, this chemical reaction is taking place in which medium? So we assume that KMnO4 is there, so we assume that a reaction is taking place in acidic medium, and in acidic medium KMnO4 always converts into Mn2 plus. Equation is ready. Okay, now you can see for Cl2 we have to calculate the data. Volume of Cl2 we have to calculate, and the data for the KMnO4 is given there. This is your 10 gram KMnO4 is given there. So now we can apply the concept of equivalence. Number of equivalence of KMnO4 is equal to number of equivalence of Cl2, and the formula we have number of equivalence. We have number of equivalence. Number of equivalence is equal to moles multiplied by n factor is there. Okay, so if we have to apply this formula, we need to calculate n factor value. So we can calculate. Equation is ready. Now first of all, we write down the oxidation number of elements on both sides of the equation. 4 to 8, potassium is what? +1, then magnesium is present in +7 oxidation number. Other side magnesium is present in +2 oxidation number. Find the difference in oxidation number. +7, the side it is +2. 7 minus 2 is equal to 5. N factor value is the difference in oxidation number. We got n factor value 5 for the KMnO4. Very interesting. Now we have Cl. Always balance the number of atoms before balancing the charge. This side 2 Cl, this side only 1 Cl multiplied by 2. 1 Cl is what? -1, then 2 Cl will be equal to what? -2. On this side this is neutral molecule, 0 oxidation number. Find the difference in oxidation number. 0 minus -2 is equal to 2. We got n factor value 2. Okay, keep in mind we have to calculate the volume of Cl2 at STP. It means if I calculate the moles of Cl2, then moles of Cl2 at STP can be converted into volume, because 1 mole is equal to 22.4 liter at STP. Very interesting part. Now let's apply the formula. Number of equivalence. Number of equivalence is equal to moles. We have moles. Moles of KMnO4 multiplied by n factor value, that is 5. Other side we have moles of Cl2, which we have to calculate and multiplied by its n factor value, that is 2. Okay, mass of KMnO4 is given there. Mass can be converted into moles. So first of all, we need to calculate molar mass, because because mass is equal to moles multiplied by molar mass. Okay, and we have to calculate moles. The moles is equal to mass by molar mass. Molar mass we can calculate for the KMnO4. Okay, pay attention carefully. We have a KMnO4. For this we have to calculate molar mass. Potassium is what? 39 plus magnesium is 55 plus 4 oxygen. Each oxygen is what? 16. 5 9 14 is there. 5 3 is 8 and 9 is there. This is what? 64 will be there. This is 8 and 158 is the gram per mole. This is the molar mass we have. Okay, mass of the KMnO4 is already given 10 gram. Okay, so moles is equal to mass by molar mass. What is the mass? We have 10 gram divided by molar mass. 158 is there. Gram per mole is there. Gram per mole multiplied by n factor value 5 is equal to moles of Cl2 gas multiplied by 2. Okay, so gram will cancel, mole will go up. Then we get 10 multiplied by 5 divided by 158 is equal to moles multiplied by 2. 2 5 is 10. Okay, now if you simplify, then we get 5 5 is 25. 25 divided by 158 is equal to, we got moles of Cl2. Okay, we got moles of Cl2. Now the last step is that at STP we can convert moles into volume, and we have to calculate. You can see option is given in liters, so we can convert 1 mole is equal to 22.4 liters. Very interesting part is there. So let's convert at STP. The relation we have at STP 1 mole is equal to 1 mole is equal to 1 mole is equal to 22.4 liter we have. Okay, interesting. Then 25 divided by 158 mole Cl2 will have how many mole, how much volume of Cl2. So then we have 25, it is what, 158, and this is mole, and then we have 22.4 liter in 1 mole is there. Okay, so mole will cancel, mole will cancel, then we got 25 divided by 158. We got 158 multiplied by 22.4 is there. If I remove this decimal, 0 will come here. Okay, so I do one thing, I simplify this expression and find out the final value. Okay, so we have 1580 divided by 224 is there, 224. Okay, decimal 0 will come here, and then one time 1580 is there, 0, and this is 8614 is there, 1 is there, 6 will come, 0 will come here. Okay, 4 5 20, 4 times we try, 0, 4 8 32, 4 5 20, and 23 will be 23. Okay, no, wait. So 4 8 32, 3 is there, 4 5 20, 23, and 4 2 6. Okay, now it is correct. 0, it is 8, and it is 5, it is 2 is there, dot. Okay, so point approximate value we are taking 0.14. So from this portion we are getting, from this portion 0.14. So we got a 25 multiplied by 0.14 is there. So we can multiply 25 4 100, and we got a 10. And then 25 1 25, and 25 plus 10 is equal to 35 is there, 35, and decimal is there. 3.5 is coming approximately a nearby value we are getting here. So see which option is correct. Which option is correct? 3.5. Okay, 3.5 we are getting option A. Okay, 3.50 we got because we rounded off when we divided this value. You can see we took approximately only 0.14, so that's why nearby value we are getting. Okay, so we got the correct answer. We have option A is correct, that is 3.54 liters. This is the volume of Cl2 at STP when sodium chloride is oxidized by 10 gram of K-4